All right, this video is for the lesson 6.4 homework. So the top of this page is tangents and radii. Radii is just plural for radius. So the relationship there. The radius of the circle is going to be perpendicular to the tangent, right? So if this is the radius, if it's a tangent line, it's going to be perpendicular to that, which means this angle is going to be a right angle. So tangents always hit at right angles to the circle. What a tangent does is it comes in and it just swoops the edge of the circle, and it looks like it touches it in more than one spot, but it literally only touches the circle at one exact point. And that's the only place that it touches it. Okay, so lengths and stuff with these. So AC, this length here, is going to equal AD because they're both radius, right? They're both radii. So if I know the distance to the edge of the circle, then I can find any other that I need. And what I end up getting is I get a right triangle. So if I know one of these measurements, I can find all the others using what we used yesterday, Pythagorean theorem. A squared plus B squared equals C squared. Okay, so when we're doing those relationships, that's how we do it. And again, it will always make a right triangle. The other relationships we have, so we've got intersecting segments. Okay, so intersecting tangent segments are equal in length from the same point outside the circle. So like this is a tangent, this is a tangent, and this is a tangent. Okay, so these two tangent lines here, from here to here, right? This distance is 15. Now I gotta remember how it works. Yeah, okay, so DE would be 15, right? So if from E to F is 15, from D to E is 15. So from the point where they hit the circle to where they intersect is going to be the same distance. And then you can use that, again, to find other measurements. And so like this up here tells you CE all the way across is 21.3. So if I know this distance, then I can find this distance. And it's just kind of a pattern. You just fill in the blank. Okay. So intersecting and then measure of the angles. So the measure of the angle formed by the intersection of two tangents outside the circle is half the difference of the measures of the intercepted arcs. So if this angle here is 53 degrees, so where these two tangents intersect outside the circle, I can take the difference of the two arcs. So the first arc is DBF, and that's called a major arc because it's bigger. And then the minor arc is the one that's in between those 2 points. So if you subtract those two values, then, yeah, half of that measure, it's kind of weird phrasing it, is the same as this angle measure. It helps when we do them to actually see one done. Again, why you need to be doing your notes the night before we do this lesson, so you kind of have an idea of what we're doing. Okay. So let's start with the tangent and the radius. So to determine if a line is tangent, this wants to know if BC is tangent. What we do is we have to decide if it's a right triangle. We can take the legs of the right triangle. So here and here. And we can plug those into Pythagorean. So 12 squared plus 16 squared. And that should be equal to the hypotenuse, 20 squared. So if we do 12 squared, not to the 12th, plus 16 squared, I get 400. And then if I do 20 squared, I get 400. If those two numbers are the same, then that line is tangent. Yes, that's a tangent line. If you work through each piece and these two numbers are not equal, then that line is not tangent. It has to make a right angle, and if it makes a right angle, then it's going to make a right triangle. If a right triangle doesn't work in Pythagorean theorem, or if the sides of a triangle don't work in Pythagorean theorem, then it's not a right triangle. All right, number 3. Find the value of x.
You have a minute. I have a question.
Is it for map?
Well, I got 2 kids from my 2nd and 3rd class.
Uh-huh.
And so I opened 5th period. Can I also open there? I don't think I can open theirs. So I'll have to do it tomorrow.
Yeah, you can only do one class period at a time. Map sucks. I wish they'd put them all in one. Okay. So here's the relationship. From here to here, what's labeled x on here is a radius. Okay? Well, from the center to any other point on the edge is also a radius. So that's also x. So I can find the value of x, again, using Pythagorean theorem. Okay? So the legs are the ones that touch the right angle. The hypotenuse is opposite the right angle. Let me grab a piece of scratch paper so I can write big. All right, so my legs here. One leg is x, so I'll plug that in for A. The other leg is 12, so I'm going to plug that in for B. How would I write the hypotenuse? What's the length of the hypotenuse from A to C? 8 plus x. Okay? If you multiply them, you're getting way too big of a number. But if it's broke down into segments, you just add the 2 segments together. This segment is x, this segment is 8. Actually, let's do it this way, x plus 8. And then that's squared. Now we're going all the way back to Algebra 1 with ones like this. Okay? So x squared, nothing changes there. 12 squared is 144. X plus 8 squared is x plus 8 times x plus 8. You remember FOIL from last year? It's coming back. F is first, so the first 2 pieces. X times x is x squared. O is outside, the outside pieces. X times 8 is 8x. I is the inside pieces. 8 times x is 8x. L is the last pieces. 8 times 8 is 64. And then combine your 2 middle terms. 8x plus 8x is 16x. So here's my equation that I have. Here's the bad news. Menu 3.1 will not solve this. Remember, Menu 3.1 does not like the exponents. Okay? So to solve one of these, combine everything that's the same. So I've got an x squared on this side and I've got an x squared on this side. I want to get those together. So I've got to subtract, and it doesn't matter which one you do. I'm going to subtract x squared from this side. X squared minus x squared cancels. X squared minus x squared cancels. Didn't touch 144. Didn't touch 16x and 64. I got numbers on either side. So again, this is now we're to a 2-step equation. This can be Menu 3.1. Okay? I'm going to do it by hand just for the sake of doing it by hand. What is that? 80? 144 minus 64? Yeah. 80. So that cancels. And then I divide both sides by 16. Again, this equation you can now stick into Menu 3.1. But we've got to start getting away from that. 80 divided by 16 is 5. And so that's the value of x. They get more complex. There's not any in this one that are harder than that, but you do have to do one by yourself. Sorry, this is getting blurry again. Okay. All right. Other relationships. So these are the intersecting ones we were talking about. It says CE, so the total distance across this is 26.51. BC, EC, and EF are all tangent. That's important. If it doesn't say they're tangent, you can't just assume that it's a tangent line. Okay? This says find the length of EF. So EF is this distance here. All right, so here's the rule. If BC is 17, then DC is going to be 17. So from where they touch the circle to where they meet is going to be the same distance. Okay. All the way across this line is 26.51. So if I know this piece is 17, I can subtract and get this piece, 9.51. If ED is 9.51, then EF is 9.51. So you just kind of have to work your way through the pieces. So again, these get more complex. We'll get this one at least set up. So this one says find the length of EF. Okay, so see how you've got these two sides and they're both labeled? Remember, BC is equal to DC, so you can set those equal to each other and find the value of X. Once you find the value of X, you can plug it in this expression and find the length of ED. If you know the length of ED, then you can find the length of EF because they're the same. Okay? You start getting twisted on that one, you let me help you. Okay, angle measures. Again, it's telling me that the lines are tangent, and it tells me arc DBF. So that's from D to B to F is 223. So if from D to B to F is 223, this distance, let's go this way, is 223. What would this arc measure right here? How would I find it? So 360 minus 223, because remember all the way around a circle is 360. So this one is 137. So to find DEF, DEF is this angle that's right in here. I can take the two arc measurements and subtract them. Okay? So I'm going to take 223 and I'm going to subtract 137. And that gives me 86. And then I take that and I divide it by 2 to get the angle measure. And that gives me 43 degrees. If you work the other way, you multiply. I don't know if I like that next one. Okay. 8's getting more complicated. We're going to go ahead and do 8 together. This time it gives me the angle measure. It says BCD is 86 degrees. BCD, that's this angle here. That angle is 86 degrees. Okay. My arcs. So I've got arc BD. That's the little one that's inside the angle. And then my big arc is DFB. Okay. We know if we add these two together, we get 360. All right, BD plus DFB equals 360. Let's say I make BD equal to X. What could I label DFB? Not Y. I want to keep all the same letters so I can solve. If I have two letters, I can't solve. What I can do is I can solve this for DFB. I can subtract an X from both sides. DFB equals 360 minus X. So when you have to go the other direction, when they give you the angle measure, one of the arcs is going to be X, the other arc is going to be 360 minus X. So the reason that I made BDX is because that's what I'm solving for. So now the big, long, scary equation. So the angle measure equals half of the big arc, 360 minus X, minus the little arc. You can menu 3-1 this, but it's parentheses city. Okay? You know what? I'm going to do this one by hand because y'all need to see it. Again, if you plan on taking Algebra 2 next year, you need to see it. So 360 minus X and then minus X. The reason you have to put all those parentheses in there is because this negative distributes and makes that a negative X. Before we can do anything, we have to combine like terms. Negative X and negative X is a negative 2X. The half distributes. So half of 360 is 180. Half of 2X is just X. And then you can solve. You can subtract 180 from both sides. You get a negative 94. You still have a negative X over here. Negative X is not your answer. You have to divide by a negative 1 to get rid of that negative sign. Okay, so you're not going to have a measure that's a negative. You're not going to have on this, you're not going to have a negative degree, a negative length, anything like that. Okay, so that one's done for you. That one was 94. All right, here we go. This is similar to what we did at the top. It's just more pieces. I'm going to see how far I can zoom in on this where we can still see it. Because I know those numbers look really, really tiny. Get as close as we can there. Okay. So it tells me their tangent, and then it tells me FG is 23.2. So from F all the way to G is 23.2. All I have to do is start filling in pieces. So if from G to D is 11.2, then from G to C is 11.2. If from E to D is 10.5, then from E to B is 10.5. Since I know the total distance of this piece, I can take the total distance and subtract this section to get this piece. Somebody do it for me. 23.2 minus 11.2. What is it? 12. If from F to C is 12, then from F to B is 12. And that's the measurement it wants, is 12. You are going to do the exact same thing on number 10. Except, once you label all the sides, you're going to find the perimeter of the triangle. So you wouldn't use this number, but you would use this one, this one, this one, this one, this one, this one. Add them all up. Should be 6 numbers that you add up. And then that will give you the perimeter of the triangle. Okay? Same exact concept. You just have to add them all up in the end. Okay. So you have